What is up, mathletes? Mr. Antonucci here, and in this video, I want to talk to you about where the Pythagorean identity comes from, and then a couple slick tricks for how to use it. The Pythagorean identity comes up in many contexts. Two of the ones that I'm thinking of primarily are when you're proving trig identities, and also when you're simplifying derivatives and integrals in calculus. Those come up, but there's a whole plethora of other contexts in which they come up. So the Pythagorean identity says that sine squared theta plus cosine squared theta equals 1. Where does that come from? Well, think about probably when you started with trig functions, you probably started with the unit circle. And the reason it's called the unit circle is because it's a circle of radius 1. Okay, so I know that at any point that I pick on this unit circle, no matter what, if I draw a line from the center to that point, the radius is 1. Center to that point, the radius is 1. Now, had I drawn this circle very accurately, it would look right, but I'm just drawing freehand now. The other thing that you probably know or learned was that the terminal point of the angle that is created right here, from the initial ray to the terminal ray that creates that angle, the x and y coordinate that's on the unit circle corresponds to the cosine. X corresponds to the cosine of the angle, and the y value corresponds to the sine of that angle, which means that this coordinate is x units over and y units up. Okay, no matter where you go. Now, when you're drawing these triangles, you have to be, and notice it becomes a right triangle if you draw the triangle in there. You always have to go from the x-axis to the point, never from the y-axis. So for this point, it would be right here. For this point, you would draw it like this. For this one, that's kind of the exception because it doesn't produce a triangle. And then for this one, it would be right here like that. Okay. If you remember from geometry, since you have a right triangle, you know that x squared plus y squared equals 1 squared by the Pythagorean theorem. Okay, a squared plus b squared equals c squared, right? The one leg squared plus the sum of the squares of the legs equals the square of the hypotenuse. So x squared plus y squared equals the radius squared, which in this case, since we're on a unit circle, the radius is 1, so it's 1 squared. So you have x squared plus y squared equals 1, because 1 squared is 1. Well, if you remember what I just told you, that x corresponds to the cosine of the angle, that tells us that cosine of theta squared plus y, which corresponds to the sine of that theta, so sine theta squared equals 1. Okay, and when you square a trig function, convention is that you put the square after the end of the abbreviation before the angle. So cosine squared plus sine squared theta equals 1. And since this is addition, you can rewrite it as sine squared theta plus cosine squared theta equals 1. Okay, and then also what's nice about this is once you know this, then you can solve for either the trig function. So if I subtract sine, I know that cosine squared theta equals 1 minus sine squared theta. And this sometimes is helpful in solving trig equations. Like if you have a trig equation that has sines and cosines, but one of the cosines is squared, you can rewrite it as 1 minus sine squared. And then this is also just getting a little bit, extrapolating what we can do with this. This is difference of squares, so you can factor it as 1 minus sine theta, 1 plus sine theta. Okay, just showing you what you can do with this. The other thing that you can do is if you subtract cosine, then you would have sine squared theta equals 1 minus cosine squared theta. And again, you could factor that if you needed to, but sometimes it helps knowing this, that if you can solve the Pythagorean identity for cosine squared or sine squared. Another thing that you can do is that if you have sine squared theta plus cosine squared theta equals 1, you can solve this to get the Pythagorean identity in terms of other trig functions. So for example, if I divide everything by cosine squared, then sine squared over cosine squared becomes tangent squared. Cosine squared over itself becomes 1. And 1 over cosine squared becomes secant squared theta. Okay, so now I have the Pythagorean identity in terms of tangent and secant squared. You notice it's a little bit different. It's not tangent squared plus secant squared equals 1. That's not, no, okay. But once you have this, then you can solve for tangent squared. It's already solved for secant squared, or you can solve it for 1, in which case you would have secant squared minus tangent squared equals 1. Okay, if you start with sine squared theta plus cosine squared theta equals 1, and you divide everything by sine squared theta, and the reason I'm showing you this is because sometimes students get trapped in this memorization loop where they try to memorize everything. But if you understand a little bit about where things come from and how to derive things, you're understanding it at a deeper level, and you're not having to memorize so many things. And then whenever you're just getting in this memorization loop, you have no idea how things are connected, and things are all disconnected in your mind sometimes. And then you start doing weird stuff that doesn't even make sense. Okay, so if I divide everything by sine squared, then sine squared over sine squared is equal to 1. Cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant, just abbreviated correctly. Okay, and now you have the Pythagorean identity in terms of, oh, I wrote cosine instead of cotangent, sorry. All right, so 1 plus cotangent squared equals cosecant squared. Again, it's not cotangent squared plus cosecant squared equals 1. Don't make that mistake. You can't just swap out the trig functions and still set it equal to 1. But if you know the Pythagorean identity, you can divide by cosine squared to get it in terms of tangent and secant, or you can divide by sine squared to get it in terms of cosecant and cotangent. Okay, and then once you have it like that, you can solve it. It's already solved for cosecant. You could solve it for cotangent, or you could solve it for 1. And lots of times it's very helpful in proving trig identities and solving trig equations and simplifying expressions involving complicated trig functions. All right, guys, hope that was helpful to you. Make sure you subscribe to the channel if you are not, and hit that bell for notifications. Drop me a comment below. Let me know if this was helpful to you. If you have any more questions about it, I can always, hop into the comments and answer some questions there. But take care and enjoy your math.